In this video, I will discuss the organic chemistry questions of JEE Mains 2013. In our first question, 4 structure of different compounds are given, and all these compounds are para-substituted phenols, and we have to compare the acidic strength of these 4 compounds. Now, to understand the acidic strength of any acid, we need to know the stability of the corresponding conjugate base. Now, what is a conjugate base? Suppose the acid is AH and it is dissociating as A minus and H plus, then this A minus is the conjugate base of the acid AH. So, as we can see that this is a reversible reaction, and the reaction will go towards the right hand side only if A minus is stable. So, if something stable is forming, then the reaction will happen, and then more and more protons will be dissociated. That means more and more protons will be coming to the solution, and the acid will be a very strong acid. So, if A minus is strong, then only the acid will be strong. So, if A minus is stable, sorry, not strong, but A minus is stable, then acid AH will be strong. Now, we have to compare the stability of various conjugate base involved in this case. So, if we check the conjugate base of compound 1 or acid 1 in this case is this one. That means an anion where the para position is substituted by chlorine, and we know that chlorine is an electronegative atom, so it will withdraw the electron towards itself. That means the negative charge on these oxygen will be delocalized, but at a very minimum level, because chlorine will only show or will only delocalize the electron by minus I effect, which is not a very prominent kind of effect. Okay, next is another compound where we have a para substituted methyl group and the negative charge is again on the oxygen. So, here also the methyl group will show some effect, but definitely it is not a negative I effect, rather it is the opposite, that is it will be a positive I effect. That means it will push the electron towards oxygen and will make the system more unstable. That means this conjugate base will not be very stable. Okay. Now, let us check the next compound, that means where the para position is substituted by the nitro group. Nitro group is very effective in delocalizing the negative charge, and that is by resonance. That means it will withdraw the negative charge from here to here to here to the nitrogen atom, to the oxygen atom, sorry. If you check in this structure, it will be easy, yes, like this and like this. So, this way the negative charge will be completely delocalized from the top of the oxygen here to the top of the oxygen here. So, this way it is much more effectively transferred from one position to another position. That means the sharing of negative charge is much more effective here, more effective than any of the other three compounds that we have seen here. Now, the next one, in this case we have an electron pair over the oxygen, but this is not going to withdraw the electron from the negative charge, rather it will push this electron pair towards the benzene ring. That means it will increase the electron density within the benzene ring itself. That means it is not going to stabilize the system, but it will work in the opposite way, or it is going to destabilize the system, and this effect of destabilizing is very prominent one. So, this will be, that means our option 4 will be the least acidic one, because the conjugate base is the least stable one. So, this is the least acidic one. And then we have this one. This is also going to destabilize the system, not as effectively as this OMe group, but it will also destabilize the system. So, 2 will be our next least stable acid. So, here goes 2. Then of course we have 1, because this one will be relatively stable. It will have some stabilizing effect at least. It will have it has the chlorine atom which will withdraw some of the electronic charge, although not as effectively as the nitro group, but definitely it is going to decrease the electronic charge density from the oxygen atom. So now I will keep 1 here, and of course the most stable conjugate base will be which is bearing nitro group, and hence the most strongest acid will be acid number 3. So this will be the order of the acidic strength. So if we check the option, we will see option 2 has this order. So this will be the correct answer. Here we have to compare the stability of these 3 carbocatons, and to compare the stability of carbocation, we need to know that how much or how effectively the positive charge over the carbocation can be easily delocalized through the system. Delocalization of positive charge means how the positive charge can be shared over the system by the other atoms. So here we can see we have 3 compounds. Compound 1, the carbocation is conjugated with a pi system, that is this one. So we have a positive charge and a pi system connected through a single bond. So this pi electrons can move from this place to this, and the positive charge will be shared by 2 carbon atoms like this. So this is quite effective, and positive charge can be stabilized. In option 2, we have an alkyl system like this. This is a primary carbocation. Actually, all these 3 carbocatons are primary carbocation. In option 2, the only effect which can stabilize the carbocation here is the inductive effect of this alkyl group. So inductive effect is just pushing the sigma electron towards the positive charge. This effect is not as effective compared to that of our first system, that is where there is a pi electron involved, but it is effective in stabilizing the carbocation when there is nothing else present in the system. So it is effective, but not as effective as our number 1 system. Okay. In number 3, the primary carbocation is directly connected with the benzene ring. Now benzene ring has lots of pi electron in it, so it can easily delocalize the positive charge like this. So here, so there are many resonance structure possible. So positive charge here, again this can move, these pi electrons can move. So another resonance structure like this. So positive charge will come over here, and then again another pi electrons can move. So yes, so this positive charge can rotate throughout this aromatic ring, and the sharing of the charge throughout the system is much more effective in case of option 3. So we can say that 3 will be the most stable primary carbocation, and then this system where we have 1 pi bond present, which can effectively share the positive charge, but not effectively as the aromatic system. So we will keep 2 in second position. Then we have the other system where there is no pi electrons at all, where we have the sigma electrons which can stabilize the carbocation by using the inductive effect phenomena, but that is not enough effective as compared to the other 2. So this will be the correct order of the stability. So 3 will be the most stable one, 2 will be next, and 1 will be the least stable one. So option 4 will be the correct option for this question. In this question, a reaction sequence has been given, and we have to identify the compound A, that means the starting material. The instructions are here. A compound A gives a white precipitate when warmed with alcoholic AgNO3. Oxidation of A gives an acid B, which has a molecular structure C8H6O4. Then B easily forms anhydride on heating. Identify compound A. We have to identify compound A. Now, the first clue is that white precipitation occurs when warmed with alcoholic AgNO3. When? Okay, we have to remember this, that when something is giving white precipitation with AgNO3 at that, and that something has a bromine in it, that means AgBr is precipitating out. So, our initial compound, that is our compound A, is C8H9Br, which is forming AgBr in presence of AgNO3. And of course, Br is a negative anion or negative ion, so the C8H9 will bear a positive charge, and we will have AgBr in the solution as precipitation, and NO3 will remain as a kind of counter anion. Okay, that's fine, but we need to know what is C8H9. We also have to remember that AgBr precipitation is only possible from an alkyl halide or alkyl bromide, not from an aromatic bromide. I mean, the bromine atom must be connected with an alkyl group, not with an aromatic group, or not with a phenyl group. So, option 1 is incorrect, and it could be anything between 2, 3 and 4. Why option 1 is incorrect? Because if I keep the bromine with the aromatic ring, and if I form this compound, that is C8H9 positive, which means something like this will form, C2H5 and positive. So, positive charge on the aromatic ring is very unstable. Why? Because the aromatic ring, the Br or this positive charge will be like this. So, this one is an aromatic ring where we have many p orbitals, 6 p orbitals, and we have these bonds. These are sp2 hybridized bonds. So, when a positive charge will create, there will be an empty sp2 hybridized orbital here, and this empty sp2 hybridized orbital is not parallel to the pi orbitals here. That means this positive charge will not be delocalized through this pi electron system. So, this positive charge will completely stay at this point without any kind of delocalization, and it will make the positive charge very unstable. So, this positive charge will not form. So, we can say that the bromine is not connected to an aromatic system. It must be connected with an aliphatic system like option 2, 3 or 4. Now, let us decide, or let us check the other clues given in this question. Now, oxidation of A gives the acid B, and acid B easily form an anhydride. So, oxidation of these 3 compound, I mean 2, 3 and 4, will obviously give a dioic acid. Dioic acid means all the 3 compound will form an acid like this. So, 2 will form an acid after oxidation, which will be like this. 3 will form an acid like this. 4 will form a dioic acid like this. Now in our second clue, it has been given that B easily forms anhydride on heating. So, easy formation of anhydride will be possible when the 2 carboxylic acid groups are near to each other. Now, if we check option 2, 3 and 4, we can see in case of 3, the 2 carboxylic acids are very close to each other. So, if we just heat it, then the anhydride will form very easily. The anhydride will look like this. C double bond O, O. This is known as phthalic anhydride, and it will form very rapidly because the two carboxylic acid groups are very near to each other, which is not possible in case of option 2 and option 4. That means option 3 is the correct answer for our question. In this problem, again a sequence of reaction has been given where A, on treating with NH3, forms B, and B on heating gives C. C in presence of KOH and Br2 gives a compound CH3 CH2 NH2. Okay. So now CH3 CH2 NH2 is an amine, and KOH Br2 is a degradation reaction, Hofmann degradation reaction. We know that an amine will be obtained by Hofmann degradation reaction of an amide, and the amide will look like this. So an amide like this on Hofmann degradation will give an amine like this. So C is of course this compound, that is CH3 CH2 CO NH2. Now C will be formed by heating of B. Now what is B? An amide will be formed from a salt of acid and amine. So the salt of acid CH3 CH2 COOH and amine is ammonia here. So this salt on heating will form the amide CH3 CH2 CONH2. So our compound B will be just a salt of this acid and this ammonia, or the base ammonia. That means A is basically the acid, because here we have seen that upon reacting of ammonia with A, B is obtained. So ammonia is coming from outside. We are actually putting ammonia to A. So A is basically the acid CH3 CH2 COOH. So if we check our option, we will get that option 3 is the correct option we have. So the overall reaction is like this, that we have the CH3 CH2 COOH as the acid, we have the base ammonia which is reacting with the acid to form a salt. So the salt can also be given like this, CH3 CH2 CO minus NH4 plus, which on heating is giving the amide CH3 CH2 NH2, which on treatment with KOH and Br2, that means Hofmann elimination, is giving us the amine CH3 CH2 NH2. So our option 3 is the correct option for this question. If you have liked my video, please click the thumbs up button as well as share the link with other people. And for more videos, please subscribe my channel and press the bell icon. Most importantly, please comment below about your needs related to chemistry so that I can make more videos on several other topics.